Welcome to the DIY Honda Garage channel. The DTC P0112 indicates a low voltage condition in the intake air temperature IAT sensor circuit specific to the 2008 to 2012 Honda Accord. The IAT sensor plays a crucial role in measuring the temperature of the intake air entering the engine, which is vital for the engine control module, ECM, to make appropriate adjustments to fuel delivery and ignition timing for optimal performance. Located near the mass airflow MAF sensor, the IAT sensor is connected to the ECM, sharing important data to ensure the vehicle operates efficiently. A malfunction in this circuit may lead to various performance issues, including poor fuel economy or increased emissions. It's essential to follow the provided diagnostic steps thoroughly to pinpoint the exact cause of the fault. Accurate diagnosis will lead to proper repairs and ultimately restore the vehicle's efficiency. The IAT sensor's primary role is to monitor the temperature of the air entering the engine. This data is critical for the ECM, which uses it to adjust air-fuel ratios for combustion. Located in close proximity to the MAF sensor, the IAT sensor is usually situated within the intake manifold or air duct system. The IAT sensor's signals directly influence how the engine functions, particularly regarding cold starts and fuel efficiency. The sensor relays temperature data via a 5-pin 5P connector, connecting directly to the ECM. If the sensor is faulty or the wiring is compromised, it can trigger a P0112 fault code, resulting in poor engine performance or increased exhaust emissions. Addressing this issue promptly is essential to avoid further complications. There are several potential causes for DTC P0112. A faulty IAT sensor itself is the most common culprit. If the sensor is defective, it can send inaccurate readings to the ECM. Poor connections or loose terminals at the MAF sensor/IAT sensor or ECM/PCM can also lead to erroneous signals, potentially causing the DTC to activate. Additionally, any short circuits in the wiring between the IAT sensor and the ECM can disrupt the circuit's function and yield low voltage readings. Identifying these issues early, using the diagnostic steps, can assist in clarifying the exact problem and allow for prompt corrective measures to restore proper functionality. If left unresolved, these causes can significantly affect the vehicle's performance and longevity. The symptoms associated with DTC P0112 can be quite noticeable. Drivers may experience poor fuel economy due to improper air-fuel mixture ratios, resulting from incorrect temperature readings from the IAT sensor. Additionally, increased emissions may occur as the engine struggles to operate efficiently under varying conditions. Performance issues, such as sluggish acceleration or rough idling, can also be indicators that the IAT sensor circuit is malfunctioning. These symptoms not only compromise the driving experience, but can also lead to further mechanical problems if not quickly addressed. Being aware of these symptoms can help drivers take proactive steps to diagnose and address the underlying causes early. The initial troubleshooting step for DTC P0112 begins with turning the ignition switch to the on position, labeled as 2. Having the ignition activated allows for the proper function of the high-definition scanner, HDS, a diagnostic tool that will be utilized to check live data. Next, it's essential to review the IAT sensor data in the data list. The expected temperature reading should be around 356 degrees Fahrenheit, 180 degrees Celsius or higher, or a voltage of 0.08 volts or lower. If these values fall within range, it indicates that the system might not have an issue at this moment and could suggest an intermittent fault. On the contrary, readings beyond these parameters will prompt you to proceed to the next troubleshooting step, helping to hone in on the root of the problem. For the second troubleshooting step, first turn the ignition switch to the lock position labeled as 0. This action ensures safety by disconnecting power as you manipulate the vehicle's electrical system. Following this, disconnect the MAF sensor IAT sensor 5P connector to isolate the sensor from the system. Once disconnected, turn the ignition switch back to the on position to enable the data monitoring again. Again, check the IAT sensor readings within the data list using the HDS tool. The expectation remains the same. Any reading around 356 degrees Fahrenheit, 180 degrees Celsius or more, or 0.08 volts or less, indicates a fault that needs addressing in subsequent steps. Should these readings not comply with the standards, transition to Step 11 for further evaluation. Upon reaching the third step in troubleshooting, power off again by turning the ignition switch to the lock position. At this point, you will need to utilize the HDS tool to jump the Service Check Switch (SCS) line, which enables diagnostics to continue without interrupting live data monitoring. Following this action, you will disconnect the ECM or Powertrain Control Module (PCM) connector C, which usually comprises 49 pins. This step is critical for checking the continuity of the circuit as it relates to the IAT sensor. The subsequent checks will determine if there is a circuit fault that could lead to inaccurate voltage readings and is vital for diagnosing any issues accurately. The fourth step involves a crucial check for continuity between the MAF sensor IAT sensor 5P connectors terminal number 2 and the body ground. This testing ensures that the circuit is intact and functioning aptly. Should there be continuity, it indicates that the wire between the IAT sensor and the ECM PCM is clear of interruptions and suggests a short within that wiring may need repair. However, if no continuity is detected, you will need to redirect your efforts to Step 18 for further diagnostics and potential component replacements. Understanding the outcomes at this stage is essential, as it can direct you based on the nature of the fault found, indicating whether further repair efforts are needed or if a different component may be at fault. If you have arrived at the fifth troubleshooting step, and continuity checks have indicated a potential issue, your next step will be to turn the ignition switch to the lock position to ensure safety while replacing components. Here, you will need to replace the IAT sensor if previous steps confirm it is faulty. After installing the new sensor, reconnect all connectors carefully to avoid any loose connections that could disrupt sensor functionality. Subsequent to this, turn the ignition switch back to the on position before proceeding with the next steps. The expectation is to monitor whether this replacement resolves the low voltage issue indicated by the DTC P0112, thus ensuring all connections are sound and the new sensor is operating as intended. Having successfully replaced the IAT sensor, the sixth troubleshooting step involves turning the ignition switch to the on position once again. This action enables the initial diagnostics post-repair, allowing the system to recognize the new component. It's time to reset the engine control module, ECM, or powertrain control module, PCM, using the HDS tool, clearing any prior error codes from the memory. Following the reset, performing the ECM or PCM idle learn procedure is vital for ensuring that the new IAT sensor integrates smoothly with the engine's parameters and behaviors. This procedure allows the ECM or PCM to recalibrate its algorithms based on the new temperature data. Ultimately, this step is essential for restoring optimal engine performance and should be completed before assessing newly pending or confirmed DTCs. After executing all troubleshooting and repair steps, The final verification involves checking again for any pending or confirmed diagnostic trouble codes using the HDS tool. At this point, the system should report no DTCs, indicating that the low voltage condition in the IAT sensor circuit has been resolved. Moreover, it is crucial to verify that the IAT sensor's readings align accurately with expected temperature values, confirming that the new sensor is functioning as intended. Additionally, assessing the overall engine performance post-repair will help ensure that no related issues persist. Successfully completing these verifications confirms the repair's effectiveness and ensures that the vehicle is ready for optimal operation without further complications. Preventive maintenance plays a vital role in sustaining the performance and reliability of the vehicle's components, including the IAT sensor and its circuit. Regular checks of the sensor connections and wiring can prevent future issues stemming from corrosion or loose terminals. Additionally, monitoring the overall engine performance routinely allows for the early detection of irregularities that may arise, serving as a proactive measure. Cleaning the intake system periodically is another important aspect. A clean air passage ensures that the IAT sensor can measure accurate readings without the interference of debris or residue buildup. Implementing these preventive measures will greatly assist in maintaining the integrity of the engine control systems and prolong the lifespan of critical components. In conclusion, understanding the role of the IAT sensor and the implications of DTC P0112 is critical for maintaining the performance of the 2008 to 2012 Honda Accord. Following the outlined troubleshooting steps will guide technicians through the diagnostic process to effectively identify and rectify faults that may trigger this code. Proper recognition of symptoms and potential causes assists greatly in streamlining the repair efforts. Furthermore, implementing regular preventive maintenance will help to mitigate future issues and sustain optimal vehicle performance. Addressing these aspects comprehensively ensures a well-functioning vehicle, enhancing both efficiency and the driving experience. Please like and subscribe to the channel. See you next time.